Welcome back to the Neural Pulse, the show where we dive deep into the brains of the machines we use every day. I'm your host, Alex, and today we're talking about alignment. It's that invisible process that makes sure an AI doesn't just give you a correct answer, but a helpful and safe one. But there's a bit of a civil war happening in the AI research world right now. Two big techniques are battling it out, PPO and DPO. Joining me to settle the score is Dr. Taylor, a leading researcher in LLM alignment. Taylor, thanks for being here.
Thanks for having me, Alex. It's a fascinating time to be looking at this. We're essentially trying to figure out the best way to teach these models what humans actually want.
So, before we get into the versus part, let's start with the basics. We keep hearing this term alignment. In plain English, what are we actually doing to the AI?
Think of it like this. Pre-training is like giving a student every book in the library. They know everything, but they don't know how to behave in a classroom. Alignment is the finishing school. It's where we teach the model to be polite, follow instructions, and avoid saying things that are harmful or just plain weird.
And the gold standard for this has been something called RLHF, right? Reinforcement learning from human feedback.
Exactly. Humans rank two different AI responses. Say response A is better than response B, and the model learns from those rankings. For years, the king of RLHF was a method called PPO, or Proximal Policy Optimization. It's what powers the heavy hitters like ChatGPT and Claude.
But then a new challenger appeared, DPO.
Right. DPO stands for Direct Preference Optimization. It came out and basically said, hey, PPO is too complicated. It requires building a separate reward model, a sort of mini AI that acts as a judge, before you even start training the main AI. Why not just skip the judge and train the main AI directly on the human preferences?
That sounds way more efficient. If I can skip a step and get the same result, why wouldn't I?
And that's exactly what happened. In academic benchmarks, DPO started winning. It's easier to code, it's faster, and it looked like it was the new champion. But a recent paper we're looking at today, Is DPO Superior to PPO?, decided to pull back the curtain.
And what did they find? Was the new king wearing no clothes?
Not exactly no clothes, but maybe just a very thin shirt. The researchers found that while DPO is great for simple tasks, it has some fundamental flaws when things get complex.
Okay, so why is this simpler method failing?
It comes down to something called out-of-distribution data. Imagine you're teaching a dog to sit using treats. PPO is like having a trainer who understands why the dog should sit. Even if the dog does something slightly new, the trainer can still judge if it's good or bad.
And DPO?
DPO is like just having a list of good dog and bad dog photos. If the dog does something that isn't in your photo album, something out of distribution, DPO gets confused. It might actually reward the dog for doing something weird just because it doesn't look like the bad photos.
So it's essentially a memorization problem?
In a way, yes. DPO can find biased solutions. It exploits the gaps in the data. The paper showed that if the model generates a response that's very different from what it saw during training, DPO might fail to align it correctly. PPO, because it uses that separate reward model or judge, is much more robust. It can generalize better to new situations.
But if PPO is so much better, why was it losing to DPO in those academic tests earlier?
That's the aha moment of the paper. It turns out PPO is just really finicky. It's like a high-performance sports car. If you don't tune the engine perfectly, a regular sedan, the DPO, will beat it in a race.
So the researchers figured out how to tune the engine.
Exactly. They identified a few secret ingredients, things like advantage normalization, using large batch sizes, and something called EMA updates for the reference model. When they applied these best practices, PPO didn't just catch up, it blew DPO out of the water, especially in hard stuff like coding competitions.
Coding? That's interesting. Why coding?
Because coding has a very clear right or wrong, but a million ways to get there. It's the ultimate test of whether a model actually understands the goal or is just mimicking patterns. PPO crushed it there.
So to wrap this up, DPO is the easy-to-use tool for quick alignment, but if you want the absolute best performance, the ChatGPT level smarts, you still need the heavy lifting of a well-tuned PPO.
Spot on. The alignment paradox is that the harder method is still the superior one, provided you have the expertise to handle it. We're moving away from what's easiest back to what's most robust.
Fascinating stuff. Taylor, thanks for breaking down the battle of the algorithms for us.
My pleasure, Alex.
And that's it for today's episode of the Neural Pulse. If you want to read the full paper, check the link in our show notes. Don't forget to subscribe, and we'll see you in the next one.